Is there a part of physics and astronomy that really confuses you?
Yeah, lots of parts of physics and astronomy really confuse me.
Quite a lot of it, actually. Certainly classic things like quantum physics. Very few people have any kind of intuitive understanding of it, and I certainly wouldn't count myself as one of them.
Oh, many areas. I guess, and there are some areas where if it doesn't confuse you, that really just tells you that you haven't understood it. So things like quantum mechanics and relativity, where the universe really behaves in a completely counterintuitive way. If you really think, well, that's pretty obvious, then I would say that almost certainly means that you really haven't understood it. And it's only when you're really confused by it that you're really getting close to understanding it.
Yeah, how did the universe begin? I mean, what happened before the Big Bang? We can describe very detailed results of it and make predictions, but what initiated it? No idea, no way to figure it out.
Which bits, where do you want me to start? I can cope with a lot of the subjects. String theory is way, way beyond me.
The difficulty with string theory is that I guess I'm an experimentalist. I do dabble in theory now and again, but what I want to see is a connection with experiment. I want to see a connection with observations. It'll be and with string theory, sometimes it's very difficult for me to see what that connection is. I can appreciate to some extent the elegance of the mathematics, and I can appreciate why string theorists get so excited. They go, well, look at the beauty of this, look at it, has to be right. But just because it's beautiful and just because it's elegant mathematics doesn't necessarily make it right. So string theory.
And it's not frustrating that I can't figure out how to answer it. It's frustrating that I don't even know how we can get any information from there. How do we go about answering that question? I have no idea, and that's really frustrating.
I find the idea of quantum computation very difficult. The basic principles, I suppose, are not so hard if you're a professional scientist, but how you're going to set up the qubits and then manipulate them and then read out the information on any useful scale. There's a lot of optimism about it. I guess maybe because I'm old, I'm very skeptical about the whole thing, about how you're going to actually make a useful machine out of it, but maybe I'll be proved wrong in 20 years.
I find general relativity, I spent one summer writing notes for myself on general relativity, so at least I had some understanding, but it is beyond me.
They're usually to do with interfaces, where you think you have a little bit of knowledge on one and a little bit of knowledge on the other, and you should be able to join the two together, and they don't quite work. So, for example, in the field that I work in, I sometimes overlap with a cosmologist who think about galaxy formation, and so the onset of what's going from the linear to the non-linear regime, where you can do everything nicely on pen and paper, work everything out on the linear, and then it can't keep doing that. Gravity takes over and it becomes non-linear, and that interface I find quite difficult because I should be able to do it, but I can't quite get it sorted out.
Thermodynamics I always struggled with a bit at university. Yeah, that was not one of my best courses.
There are lots of things which are really quite technical, which I can cope with, but when it gets to general relativity, it goes off into another area.